Hello and welcome. In this video I want to show you some more examples of finding limits involving absolute value. The first limit is this. What is the limit of 1 over x minus 1 over absolute of x as x approaches 0 from the positive side, from the right? If you remember from the previous video, to find limits involving absolute value, first we have to try to get rid of the absolute value in the expression. So we have to try to get rid of this absolute value. And to get rid of the absolute value, always we use this rule. Absolute of an expression equals the original expression if f of x is positive, and equals negative of f of x if f of x is less than 0. So if f of x is greater than or equals 0, absolute of expression equals to the original expression. But if inside the absolute is less than 0, the absolute of that expression equals negative of that expression. So based on the definition, actually this is the definition of absolute value, we can get rid of the absolute value. Now attention to this question. X approaches 0 from the positive side, so x is a number. X is something that approaches 0 from the positive side. So x is greater than 0. And when x is greater than 0, this means that this expression that is inside the absolute is a positive expression. And when something is positive, we have this case. Absolute of that expression equals to the original expression. So absolute of x equals x, simply x. So now that we know that absolute of x is x, we can rewrite this limit as 1 over x minus 1 over x. And 1 over x minus 1 over x is simply 0. This 1 over x cancels with this 1 over x, and 1 over x minus 1 over x is 0. Before I show you the next example, let me tell you that this original limit that we had here is an indeterminate form. We cannot find this limit just simply by substitution, by direct substitution. If you plug in 0 here, 1 over 0 is infinity. Note that x is not 0, x approaches 0. And when we have a number, non-zero number, over something that approaches 0, it's infinity. The other one is also infinity. 1 over 0 is also infinity. Infinity minus infinity is indeterminate form. And in this case, we prove that this limit is 0. But not always any infinity minus infinity is 0. No, it's an indeterminate form. It can be any number. In this case, we got 0. Let me show you the next example. What is the limit of 1 over x minus 1 over absolute of x? Same function, same expression, but this time x approaches 0 from the negative side. For finding this limit, note that x approaches 0 from the negative side. F of x is less than 0. The expression inside the absolute x approaches 0 from the negative side. So x is a negative number. And when f of x, when the expression inside the absolute is negative, absolute of that expression is negative of f of x. So absolute of x is negative x. So we can write this limit as 1 over x minus 1 over negative x. Minus 1 over negative x is actually plus 1 over x. This negative with this negative cancel each other. So basically we have this. 1 over x plus 1 over x. 1 over x plus 1 over x is 2 over x. So this limit equals limit of 2 over x as x approaches 0 from the left. Any number, it doesn't matter what is the number in numerator, over something that approaches 0 is infinity. But it can be positive infinity or it can be negative infinity. Which one in this case happens? The number in numerator is 2, it's positive. X in the denominator approaches 0 from the left, so x is a negative number close to 0. Top is positive, bottom is negative, so the limit is negative infinity. So this limit equals negative infinity. The right limit of the expression was 0. The left limit of the expression is negative infinity. So we have completely different answer. So if we want to find limit of x approaches 0 in general from two sides of 1 over x minus 1 over absolute of x, what would be the answer of this question? The answer is simply the limit does not exist, because the left limit and right limit, as you can see, are different, and when this happens the limit does not exist. Let me show you another example. We want to find limit of absolute of x to the 2 plus x over x as x approaches 0. This is a two-sided limit, and probably you know that you cannot find this limit right away in this form, because we want to get rid of the absolute, and to get rid of the absolute we need to know usually x approaches the number that is here from which side, from the left or from the right. And because this is a two-sided limit, x can approach 0 from the left and from the right. So first we are going to write this limit as two separate limits as this. X approaches 0 from the right, x approaches 0 from the left. This is what we are doing usually when we have absolute value. So we want to find the limit from the left and from the right separately. Now let's see, the expression inside the absolute is positive when x approaches 0 from the right, or negative. If x approaches 0 from the right, it means that x is a positive number close to 0. Something like 0.1 you can have in your head. This is not right, but it helps you to figure out. When x approaches 0 from the right, x is positive, of course, and x to the 2 is always positive. It doesn't matter x is positive or negative. X to the 2, we know that always for any value of x, x to the 2 is positive. X to the 2 is positive, x is also positive, so x to the 2 plus x is positive. And when the expression inside the absolute is positive, the absolute of that expression equals itself, equals the original expression. So the first limit would be limit of x to the 2 plus x over x as x approaches 0 from the right. We will back to this limit in a moment. Let's see what happens here. When x approaches 0 from the left, x is close to 0 but less than 0. Again, you can have this number for x, negative 0.1. This is a number close to 0 but from the left. And attention, this is not mathematically right, and it doesn't always work to consider x a number like this. If x is negative 0.1, x to the 2 would be positive. I told you, x to the 2 is always positive. We know this. X to the 2 for any value of x is greater than 0. And negative 0.1, of course, to the 2 is positive. It is 0.01. So x to the 2 would be 0.01. But x itself is negative 0.1. The sum of these two, of course, is negative 0.09, and it is less than 0. But this is not really a mathematical way to show that when x approaches 0 from the left, this expression is less than 0. This is just an example that it shows that the expression inside the absolute is negative. But how we can prove mathematically that the expression inside the absolute when x approaches 0 from the left is negative? Let me show you. We are going to factor the expression inside the absolute. We can write it as x times x plus 1 over x. Now attention, if x approaches 0 from the left, the x here is negative, because x approaches 0 from the left, x is less than 0, so x is a negative expression. But when x approaches 0 from the left, x plus 1 is positive. Why? X is close to 0, very close to 0, and it's negative. But when we add 1 to x, x plus 1 would be positive. X is negative, x plus 1 is positive. So overall, if we multiply them by each other, x to the 2 plus x would be a negative expression. So we proved that when x approaches 0 from the left, x times x plus 1 is a negative expression. And now, based on the definition of absolute, remember this is the definition of absolute. Absolute of any expression. If the expression is negative, equals negative of that expression. So absolute of x to the 2 plus x, which we have here, or absolute of x times x plus 1, again, I should emphasize on this, x times x plus 1 is actually x to the 2 plus x, but we factored it this way. So absolute of that of this expression would be negative of that expression. So we have limit of negative of x to the 2 plus x. Again, why we did this here? We did this middle step here to figure out x to the 2 plus x is positive or negative. We proved it this way that x times x plus 1 or x to the 2 plus x is negative, and when expression is negative, absolute of that expression is negative of that expression all over x as x approaches 0 from the left. Now let's back to this limit which we had here. Simply, if we factor x, x from the top with x from the bottom cancels and only remains x plus 1 as x approaches 0. If we substitute 0 for x, 0 plus 1 would be 1. So the right limit is 1. If we factor this, it is x times x plus 1, x with x cancels, and what remains is negative of x plus 1 as x approaches 0. If we substitute 0 again here, 0 plus 1 is 1, but don't forget we have a negative, so negative 1. The left limit and right limit are different. So what would be the original limit? Does not exist. Why the limit does not exist? Because the left limit and right limit are different, so the limit does not exist. I hope you liked this video. If you like this video, please subscribe in my channel and see you in the next videos.